Assalamu alaikum, welcome to my sweet kittens. So today we're going to start with the chapter 14, which is about introductions to organic chemistry. The first definitions that we're going to start with in this day is the hydrocarbons. Hydrocarbons. From its name, you can deduce what does it stand for in here. So it stands for a compounds of carbon and hydrogen only. This definition came in one of the past papers, and it was like define the hydrocarbons. Defining the hydrocarbons, you should say it's a compound that is made of carbon and hydrogen only. You have to say only. Okay, we have another thing to understand here. Look at this. By the way, this question is also a past paper question, and it says that which of these compound is hydrocarbon. So according to the information that you were given here, it says that the hydrocarbon is made of hydrogen and carbon only, okay? And as we can see here, we notice that this compound contains a chlorine, so it's not hydrocarbon. But if you look at this one here, you have hydrogen and carbon, so it's supposed to be hydrocarbon, so the answer is B. Look at this, it contains hydrogen carbonate. And by the way, put a note here, it's not hydrocarbon. And if you look at HCl3, it's hydrogen carbonate. Put in your mind, hydrogen carbonate is inorganic. Okay, it's inorganic material, or say compound. It's not organic, even though you have hydrogen and carbon, but in this case, hydrogen carbonate are inorganic. These are not organic at all. So my question is, how can we represent the organic compounds? How can we represent them? So we can represent the organic compounds by different formula, like empirical, molecular, structural, displayed, and skeletal. So let's start with the first one, which is empirical formula. What you should know about empirical formula, it gives you the least details. It doesn't give you a lot of information about the molecule that you have. So it gives the least details. And put in your mind, it's the simplest ratio. Okay, and it's calculated experimentally. It means that if you want to calculate the empirical formula for any certain compound, you should understand that you can do that in the science lab. You can do that experimentally. You can do that in terms of only calculations only. You have to do it experimentally, then apply some calculations, then you can find the empirical formula. Okay, so can we take an example of the empirical formula? Yes. Look at this equation here. This equation came in 2021. The question says, a compound X is an organic compound that contains these percentage of carbon, hydrogen, oxygen, and chlorine. This is organic, but it's not hydrocarbon molecule. So the question says, what is the empirical formula of X? How to write the empirical formula? First of all, you have to put in your mind, the empirical formula is written like this. You will say, like, you have carbon, hydrogen, oxygen, and chlorine. So the given percentages in here, let's say, are in terms of mass. So the carbon here is 30/6. For hydrogen, it's 3.8. For oxygen, it's 20.4. And for chlorine, it's 45.2. Then you will change the mass to moles by dividing these amounts over atomic masses. So according to the atomic mass of carbon, it's 12, it's 1 for hydrogen, it's 16 for oxygen, and it's 35.5 for chlorine. Then you will find the answer. Just let me calculate that in here. So in this case, you're going to divide these numbers over the smallest number. Which of these is the smallest? 2.5 or 3.8 or 1.8? It's 1.82. So you'll divide these over 1.28, 1.28, 1.28, 1.28. So as we can see here, it will be 1 for chlorine, 1 for oxygen. And approximate that in term like this is 2, 2, 3, 2, 1, 2, 1. Then you have 2 carbons. You have to say like it's C2. All right. How many hydrogens? We have 3 hydrogen, H3. We have only 1 oxygen and 1 chlorine. So the answer is A, as we can see. So look at the empirical formula. So we're going to start with the molecular formula. But before we start with the molecular formula, we have to understand something about the empirical because these are related to each other. One of the most famous questions that came in the exams is how can I determine which the given formula is empirical or molecular? Is it empirical or molecular? So first of all, if I look at this one here, is this molecular or empirical? It says that the empirical is the simplest, which means, is this simple? As we can see, we have C4222, which means I can simplify this by dividing this compound over 2. So I can get C2HOCl2. So this is not empirical because it's not simplest. What about this? Can I simplify this more? You have 2 carbons, one hydrogen. No, this is empirical. This is empirical. What about this? Can I simplify this molecule? No. So let's take an example like CH2O, all right, which is the empirical formula. If we multiply the CH2O with different numbers like 2, 4, let's say 3, then you will get something called molecular formula. So the molecular formula is a multiple of empirical. So if you multiply this empirical by 2, by 4, by 3, whatsoever, what the number is, it doesn't matter, then you will get the molecular formula. So what will happen as we multiply these? So let's take the first one, CH2O multiplied by 3, you got C3H6O3. So this is molecular. You can simplify this easier. Okay, what happens if it's multiplied by 4? It will be C4H8O4. Okay, so this is another issue. Okay, so look at this compound. How can I calculate or determine the molecular formula if you were given the relative molecular mass of the molecule and you were given the empirical formula? So first of all, you will take the MR of the molecule that you have. This molecule is unknown to you. You don't know the molecular formula of this molecule. It's multiplied by 2, multiplied by 3, by 4, we don't know. So we will put the MR of this molecule over the MR of empirical formula. So how can I apply this? Look at the empirical formula. What is the MR of this molecular formula? You have 1 carbon, which is a 12, and you have 2 hydrogens and 1 oxygen. Then the answer will be 30 gram per mole. And as you can see, we can put it here. This is the MR for the empirical formula molecular mass, and it's time to calculate this. It says that the molecular formula for this molecule, which is unknown, is 120. So you can say like it's 120. As a result of these, it will give you have to multiply this 4 by this one here. So it will give you C4H8O4. So this is the molecular formula of your compound. You have to divide the MR of the molecule over the MR of the empirical compound. All right, so what do we conclude from the molecular formula? We can see the actual number of atoms. Let's take this compound like C4H8O2. Okay, so this is a molecular formula. Because you can simplify it more, then it's not empirical. So according to that, I can determine the actual number of atoms in here. Okay, and if I want to tell you about what will be the empirical formula, you can simplify this to C2H4O. So this is the empirical formula. So as we can see, the empirical formula, it doesn't give you the exact number of atoms. It gives you, let's say, the origin number of atoms. Okay, so we're done with empirical and molecular formulas. And now it's time to go to the new type of representing organic molecules, which is the structural formula. What you should know about the structural formula is it gives us more details about the atoms and the bonds. It gives us a lot of things about the framework of the compound. And it shows that whether this compound contains double, triple, or even like cycles or rings and the compound. So let's take an example like if I give you this compound C4H8, for example. So this formula here is molecular formula, right? But in this case, does this molecular formula tell me anything about whether do we have double bond Okay, if you don't know the alkanes or alkynes whatsoever, you don't know. Actually, you don't know if it contains double bond or not. So the structural formula is for this compound is written like this: CH3, CH2, CH, double bond CH2. So in this case, we can consider this as a structural because it shows the double bond in here. Okay, it shows the double bond. So I can consider this as a structural formula. Structural formula. Let's take another example, like if you have alkyne, for example, like alkyne, which contains a triple bond. We can write like CH3, CH2, C triple bond, and you have CH. So in this case, you can say like this is a structural formula. It shows us the presence of a triple bond in here. So we can see the double bond, we can see the triple bond in here. Okay, so it's more, let's say, explainable than the molecular formula. Okay, so let's go to the other thing, which is another type of formula. We go to the displayed formula. The displayed formula shows all bonds. For example, if I give you this compound like C3H8, how can I write the displayed formula for this? You have to show me all of these bonds. So this compound looks like this. You're showing me all of the bonds here. You can write all of the hydrogens in this case, right this way. Yeah, so this is the displayed formula in here. I want to give any question here. Give the displayed formula for this compound. CH3, CH, you have OH in here, and CH2, CH2Br, for example. So this is a structural formula. This is a structural. Okay, is a structural. So how can I translate the structural to displayed? This is one of the most famous questions in the exams. So first of all, you will write the carbons. You have 1, 2, 3, 4 carbons. So draw the carbons first. Okay, I draw the carbons. This contains three hydrogens, so I will draw these hydrogens in here. This is connected to one hydrogen and one OH. You have to show me the bond between OH as well, like this. And here we have 2 hydrogens. You will show me like this. What about this? It contains 2 hydrogens and 1 bromine. Okay, let's go to the last one, which is a skeletal formula. The skeletal formula tells us a lot. In this case, carbon and hydrogen simples are removed. These are removed. Okay, how can I represent a hydrocarbon, or let's say organic compound, without these simples? These are not. And the bond between carbon and hydrogen is also removed. So how can I represent any compound? We will start with examples. Suppose that you have CH3, CH2, CH2, CH3. So this is a structural formula for organic compound. And my question is, how can I represent this in terms of a skeletal? So first of all, you will start counting the number of carbons. You have 1 carbon, 2, 3, 4, right? And then you will start doing, this is 1, 2, 3, 4. So this is what carbon number 1, this is carbon number 2, 3, and 4. We can represent that in this term. Miss, where is the hydrogen? What you should know that carbon makes 4 bonds, right? Okay, so if you go to this one here, you just notice that this carbon makes a bond only with carbon in here. So there are 3 bonds for hydrogens. Don't write these hydrogens. Don't draw these. But in case if I ask you to write the molecular formula, you have to count them. So here we have 3 hydrogens. Here we have 2 hydrogens, because this carbon is connected to 2. So in here we have 2 hydrogens, and here we have 3 hydrogens. So my question is, if I ask you to draw the molecular formula formula. How can I write this, the molecular formula? You will start count the number of atoms. This is carbon number 1, carbon number 2, 3, 4. Then your molecular formula will be C4. How many hydrogens we have here? We have 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it will be H10. Let's take another example, which is a little bit complicated. Okay, if I give you this one here. Okay, by the way, this is benzene. This is benzene molecule. This is benzene molecule. And how many hydrogens and how many double bonds we have here? First of all, for this benzene, it contains 3 pi bonds. Put this in your mind. This pi bond can rotate inside this ring like this. And that's why we can represent this molecule in this form, which is in the skeletal structure, and it looks like this. So this is a skeletal formula of benzene. Okay. What is the molecular formula of this ring? Okay. First of all, you just remember that each carbon makes 4 bonds, right? So if this one, as we can see, there's a bond, this is 2 and this is 3, then there is 1 hydrogen left here. And the same here is the same for all of these, as you can see. If you count the number of carbons, then this number of carbons will be C6, right? Okay, how many hydrogens we have? We have 1, 2, 3, 4, 5, 6. Then we have C6H6. Okay. How can I represent the molecule like with a double bond, for example, or let's say with the branch, for example? Let's take this one, CH3, CH2, CH3, and here we have OH. If I ask you to change this, give the skeletal structure, or let's say formula. Give the skeletal formula. The first thing that you should know, you have to count the number of carbon. 1, 2, 3, 4. Then you say like 1, 2, 3, 4. Okay, right. This is 1, 2, 3, 4. Great. You have a branch and the second carbon. Okay. This branch is in here. By the way, you have to put the branch on the top, or let's say on the angle in here. It's not right to say like this. It's not correct. You have to put it here or here. Here or here. It doesn't matter. So in this case, it's here. Here we have OH. By the way, we write the symbol of other atoms like oxygen. Or in here we write the hydrogen. Why did we write the hydrogen in here? Because the bond that is cancelled in the skeletal formula is between C and H. But if it's oxygen with H, it's written in here. Okay? So the symbols of hydrogens and carbons most likely are removed in the skeletal formula. So in this case, this is the structure of your answers. If I ask you to deduce the molecular formula in this case, so first of all, you will start counting the number of carbons. 1, 2, 3, 4, then it will be C4, right? How many hydrogens we have? This one is on the edge and it makes 3. Here we have 3 bonds, then we have 1 left, we have 2, and here we have 3, then it will be H10, and we have oxygen. Let's take another one when we have double bond. Let's say like we have C4H8, like CH3, CH2, CH double bond, CH2. So my question is, give the skeletal formula. First of all, you will start counting the number of atoms. 1, 2, 3, 4. Then you have 4. 1, 2, 3, 4. Where is the double bond? It's between carbon 1 and carbon 2. Then you will do it like this. So this one is the same as this. Let's take another example. If I ask you to give the molecular for this compound. And this compound is kind of a little bit complicated. So suppose that you have this, you have double bond here, and I'm going to put it like this. Here we have OH, and here we have Br. So how can I take the molecular formula? Okay, first you will start counting the number of carbon atoms. We will start from this one. You can start from where you like, it doesn't matter. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, then we have C12, we have 12 carbons. As we can see, this carbon makes 2 bonds, then we have 2 hydrogens. Here we have 3 bonds, then we have only 1 hydrogen. Here you have 3 bonds, we have 1 hydrogen. Here we have 3 bonds, we have another hydrogen. 2, here you have 1, we have 2, we have 2, we have 1. Here we don't have anything because we have 4 bonds. And here we have 2, here we have 3. Then we have 19. Then we have 19 hydrogen and 1 oxygen and 1 Br. Let's take another one, which is like this. If I ask you to give molecular formula, okay, and give the empirical formula. Okay, so first of all, we are going to count the number of atoms. We will start from wherever you like. It doesn't matter at all. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it will be C10. How many hydrogens we have here? Put in your mind, you have 2 benzene rings together. So what you should know about, on benzene ring, you have only 1 hydrogen on each carbon. Okay, so we will start counting. Here we have 1 hydrogen, 2, 3, 4. We don't have here because we have 4 bonds. You have double bond from here and 4 bonds for both. So we have 1, 2, 3, 4, 5, 6, 7, 8. Then it will be H8. Okay, so if this is molecular formula, what about the empirical formula? Empirical, can I simplify it to divide this over 2 over 2? Then you will get C5H4. So this is the empirical formula of your compound, and this is the molecular.